Good afternoon, everyone. At first, I want to introduce myself. I'm Ali, I'm a master's student in Mumbai University. My project, we're talking today about the thin film lithium-ion battery. This very interesting kind. Let's go to another slide. Another slide, I will use the outline to be something like constructor to can explain all my information very well. Let's start from introduction. Let's know what does mean thin film lithium-ion battery. This kind of battery belongs to the second battery family. Okay. Here, the thin film lithium-ion battery is a form of solid-state battery. It is used both solid electrodes and solid electrolyte. This is the last two words, will be the most important things here in this kind of battery. I will explain all of that in the next slides. Now let's talk about another feature. This kind of battery is very thin. This picture is straight to us, this feature. And because actually it's like paper. Because this feature, we can use it, we can benefit very well. I will explain that in the next slides. Here, let's talk about the components of the thin film lithium-ion battery. What the important elements here in this battery? I will start from the electrolyte because that's very important. Actually, all of them is very important, but I started from electrolyte. Electrolyte, this thing take the place between the two electrodes in this kind of battery. All we can say in all the batteries we have the electrolyte. Honestly, not just in the thin film lithium-ion on the same system, but we have one different. I will explain it. At first, the electrolyte take this place between the two electrodes, anode and cathode. But here we have different, make this feature, make this kind of battery be different from the other. It is the greatest difference between the classical lithium-ion batteries and thin flexible lithium-ion. Because here will be the electrolyte here is material, not like the other. Because in the other, we can say something like water, not just real water, aqueous. Can't say aqueous. This word be more appropriate to explain the situation. The solid electrolyte used for ion condition between anode and cathode, like I said before. The benefit, let's go directly what his job. His job actually to prevent the spark, to prevent the direct spark between anode and cathode. Because we know, and anyone know, if we facing spark between cathode, minus charge and positive charge, the system will explosion. No way, we will lose our system, we will lose cost of money, because that is very important. Okay, where his place, like I said before, take the place between these two electrodes. All this space, the electrolyte will take it. Okay, let's go to another slide. Now let's talk about the separator. What is the separator? The separator is, we can explain it very well by using these words, is a mesh sheets material. His place at the the electrolyte. What the benefits from it, or we can say what his job. His job to support the electrolyte in this battery, because actually it like a wall to prevent the electron to prevent the charge from move from side to side. Sure, and sometime will prevent it, and another time in charge or discharge, we will let all of them through from him, but that will be automatically and we will control on it. Okay, now let's go to another slide here. Now let's talk about another component, another element will be the current collector. We know, and anyone know in physics department, sure, in any electric device and any collectors, we have current collector. There's the same thing with the solar cell and solar cell system, I mean. And any devices, any electrical devices, we have current collector. Now, this picture will illustrate to us here some important things about charge and discharge and how all these current collector will move between these two electrodes. Now let's talk about the discharge. The current collector, the charge, move from the negative anode to positive cathode. And on discharge and in charge, when put our devices on the charge, what will be the current collector, the charge, the current will move from a positive cathode to a negative anode. Now let's talk what the current collector must be. It must be, number one, flexible, high surface area, be cost effective. This is very important in any current collector. They are normally metal oxide that are deposited as a film by various methods. Let's go to another slide. Here, this will be the last element of thin film lithium-ion battery, cathode and anode material, like I said before. Here, this image illustrates to us here the anode, the minus charge, and we support this electrode by putting carbon wafers. And here the cathode is positive charge and electrolyte between them, and the charge and the current collector, the charge move here and discharge to the side, and in charge come back to the side. They are normally metal oxide that are deposited as film by various methods. And we can't forget this important information, important feature. It's in thin film lithium-ion battery are the same in classical lithium-ion batteries. That means in this element, in this component, we don't have any different with the another kinds of battery. As the same, just the big important different was the electrolyte. Now let's talk about the advantages here and why this kind of battery we could using in our life very wide, and how why this kind of battery helping us to make our life be easier. Okay, sure, because this kind of battery is very rich about advantages, features, make him be distinguished from the other kind of battery. Let me explain all of that. I will start from number one. They are much smaller in size, a great performance, higher average output voltage, lighter weight, higher flexibility. Let me stop here and put a clear example to illustrate all of this. For example, the credit card project. Now, in our life, we have anyone in our life here have credit card one or more in his package, and we use it and we leave the cash money anymore. Okay, let's come back to our project. Project like that, very small, very lighter weight, need charge. And in the same time, that's clear, to make project like that be successful, we need a power source, we need battery, smaller than him and lighter weight than him. Because technique like that, now we left the cash and we use the credit card technology. Let's talk about the higher flexibility, like this image. It's actually like paper. We can draw any figure by use this distinguish. Actually, after I had a lot of research, I noted by the manufacturing and the mobile phone, we use this feature, we're using this feature by do something like sandwich like that, and after that put it in the cup. This in manufacturing a mobile phone. That means it's very helpful to us to make a great battery to our phone, because in our life today we have a big screen, we have Bluetooth, something like that. We have many applications. All these applications sure need power, because that we must generate more advantage battery. Now let's come back to the other advantage. Low chance of electrolyte leakage. Long life cycle, wow, reach 2,200 cycles. After that will be losses. But 1,200 cycles, that's not small number at all. Withstand temperature of minus 40 to 150 Celsius. That's huge rate here. The battery like that can hold on between these two numbers, because that I think this kind of battery will be great in astronomy field, because when we leave our world, the temperature will be different. Sure, maybe if we be near from the sun, the degree will be more 100, 120, something like that. And when we go to another planets far away from the sun, the degree will be minus 30, minus 35, we don't know. Because that this kind of battery will support astronomy field strongly. And we know when we live our world, we need cycle we need battery has longer life like that. Now let's go to another slide. We have more pictures more than, but I selected just these. I'm thinking this will be better, will be enough. Okay. Applications of thin film lithium-ion battery, because these many advantages we can use for many applications. Like I said before, in credit card project, in smart glasses, in smart watch, in robots. And this picture explains to us the flexibility to this kind of battery. After that, after I had a lot of research, I selected ultra thin to be the great example to illustrate to us this kind of battery, thin lithium-ion battery. Now, let's talk about ultra thin characteristics, because his characteristics, I selected it. Okay, let's go and see what his characteristics. Special shaped batteries ranging in thickness from 8 millimeter to as thin as 0.4 millimeter. That means less than 1 millimeter, less than 1 millimeter. The biggest characteristics here of and this thickness of the wall battery can be as thin as paper. And this picture is great because could illustrate this feature very well. Like paper, you know, without anything, like paper. Okay, and on another hand, because this kind of battery is very rich of advantage, paper, and in the same time, we have another great features like long cycle life, low shell consumption, and the safe. In my opinion, in any battery, in any kind of battery, if we really need successful battery manufacturing, we must focus on these three things: the cycle life, the shelf consumption, and the safe. Must be safe, no way. Now, let's go about the challenge. In any battery, in any thing in our life, sure, like it has an advantage and at the same time has disadvantage. We can say to disadvantage setup, we can say challenge, the same meaning. Material proliferation. Silicon is an allow anode and each silicon atom can host 4 lithium atoms. When transforming from silicon to lithium-4 for silicon, the volume expansion is about 420-100%, the large volume expansion, construction during lithium insertion, and many things like that. Because all these disadvantages, all these challenges, all that will leading to loss of electrical contact and capacity feeding, and that's terrible. Now, let's go to the most challenge, not in just lithium-ion battery, actually. Honestly, in all the batteries, and the secondary batteries, difficultly use the same disadvantage, the same challenge. This challenge here is the SEI, this simple 3 words, that mean solid electrolyte interface. Here, in a stable SEI, let's explain and focus on this part very well because I believe that's very important. And if we can solve this problem in near future, we will have successful battery anyway. No one can say something not like that. SEI, that's mean the solid electrolyte interface. This disadvantage facing all the batteries, the secondary batteries, not just the lithium-ion, like I said before, because when the ions moving and the charge moving, in charge and discharge, like we say, this disadvantage will be because the ions will start to build something like wall in the separator. This will work to prevent the electrons, the charge, the ions from moving through it. Because that, the efficiency of the battery will be, we will lose the efficiency actually of this battery by charge, discharge, day by day, because this disadvantage. Now, the SEI, the solid electrolyte interface, crashed due to volume change of silicon anode during cycling. Cycling, that's mean charge, discharge, and still using it. The exposed fresh electrode surface leads to very thick, something like wall on the separator, like I said before, SEI layer, resulting in disadvantage. Because disadvantage, we will face 3 horrible things. Number one, low Coulombic efficiency, low electronic conductivity, and the last and terrible thing is higher resistance to ionic transport of the whole electrode. Now, after all this great information about lithium-ion battery, let me do something like summary. The lithium-ion has many advantages, like I said before. Actually, it's rich about the advantages and features, benefits. The most important, the size, weight, flexibility, life cycle, like I said, and the great last one is withstand temperature. The important challenge and disadvantage is SEI. We can't ignore it. Components of the important elements here: electrolyte, separator, current collector, cathode and anode materials. After that, I selected the ultra-thin battery to be the clear example. And it belongs to thin film battery, sure, and it is the best example to it, like I said before. Now let's talk about the conclusion. Thin film battery will be number one in near future. After, sure, this condition, let's focus on this. After find a solution to SEI problem, or not solution, or if we can put limit to this disadvantage, this kind of battery will be the number one. No way. No one can say another thing. And because the two important feature, the long cycle life and the small size, safe and other. Here, sure, by this kind of battery, many people were received. Let's talk about this note. Like the last example, when I was talking about the credit card. In the medical field, sure, this kind of battery can be helpful because, for example, we know many people's suffering from some problem in their hearts. That's mean after the technology, now we can make something like electronic heart. Let us imagine, do imagination together. If we have electronic heart, sure, we need battery, we need power source to it, and this heart is not big, like the size about the normal heart. Because that we will need a great source of battery, and in the same time must be small and lighter. That's mean and the long cycle life will support this case, because we know this surgery like that, it's not easy at all, because maybe we will lose his or her life. Because that we will need long cycle life, because we will put this surgery, we will put this battery, this electronic heart, and after that maybe this maybe leave this this part, this electronic heart, to long time, because that in my opinion this is great and helpful to the all humanity. Okay. This resource, I used all of these. Anyone can check my information. Okay. Thank you so much about your listening. I appreciate your time. Teşekkür ederim. Hepinize kendinize bakın. Hoşça kalın. Eyvallah.